Have you ever pondered the heights to which we could jump on other planets in our solar system? Think of jumping over mountains on Mars or leaping over tall structures effortlessly on Jupiter. How high we can jump is greatly influenced by each planet's gravity. On Earth, gravity keeps us firmly on the ground, but on Mars, where gravity is just 38% as strong as on Earth, we could jump far higher. Jumping would be much harder on the gas giants Jupiter and Saturn because of their much larger gravitational fields. Watch this video to the end to discover how high we can fly on other planets in our solar system as we explore the exciting world of planetary jumping. In the 1950s and 1960s, NASA undertook research to establish how the gravitational pull of other planets would impact the human ability to leap. This research calculated how high a person could jump on each planet using data from early space missions and mathematical computations. According to the data, jumping would be challenging on worlds like Mars and Venus because of their weaker gravitational pull and thicker atmospheres, but more straightforward on planets like Jupiter and Saturn because of their more potent gravitational force. Watch the entire video to learn more about how high we can jump on other planets. Please give this video a thumbs up and subscribe to this channel for more videos. Before we proceed, click the bell icon to receive notifications of new videos. Have you already done this? Let us start. Let us first study the environmental changes occurring on these planets, such as various day lengths, different atmospheres, and so forth. Each planet in the solar system has unique environmental characteristics such as temperature, composition, mass, and gravitational force. There is a considerable difference between the planets in our solar system, starting with the duration of days or the time it takes for a planet to complete one rotation around its axis. On Mercury, a day lasts only approximately 58 Earth days, but it lasts roughly 10 hours on Jupiter. The planet's varying rotating periods, with those closest to the Sun having shorter durations and those farther away having more extended periods, cause this fluctuation. The composition and thickness of the planet's atmospheres also differ substantially. While Mars's atmosphere is mainly made up of carbon dioxide and is thin, Venus's atmosphere is primarily made up of carbon dioxide. Venus is the hottest planet in the solar system due to its dense atmosphere, which produces a greenhouse effect that results in surface temperatures reaching up to 864 degrees Fahrenheit. Mars, in comparison, has a thin atmosphere and a surface that often hovers around 80 degrees Fahrenheit. Hydrogen and helium make up the majority of the composition of gas giants like Jupiter and Saturn. In contrast, metals and silicates make up most of the composition of rocky planets like Earth and Mars. The separation of a planet from the Sun also affects the makeup of its atmosphere. Lighter gases like hydrogen and helium escape from the vicinity of the Sun due to the high heat and radiation, leaving denser gases like carbon dioxide and nitrogen behind. The makeup of its atmosphere also influences a planet's temperature. For instance, Venus's high surface temperatures result from the greenhouse effect, which is brought on by the planet's thick atmosphere, mainly made of carbon dioxide. The thin atmosphere of Mars, on the other hand, cannot hold enough heat to keep the planet warm, resulting in its cooler surface temperatures. The seasons, weather patterns, and geological activities of the planets in our solar system all change along with these environmental changes. The seasons change on Earth because of its tilt and orbit around the Sun, whereas violent storms like the Great Red Spot occur in Jupiter's enormous atmosphere. Volcanoes and plate tectonics are examples of geological activity on some planets, including Venus and Mars. How far can you leap on various planets? An average Earth person can leap a vertical distance of around 0.45 meters in 1 second. The identical jump, however, would reach a height of 0.17 meters on Jupiter due to Jupiter's significantly higher gravitational attraction due to its much greater mass, more than 300 times that of Earth. Since Neptune has somewhat greater gravity than Earth, an average jump would be 0.39 meters high. Venus, Uranus, and Saturn all have the surface densities roughly equivalent to Earth's. The average hop would be 0.49 meters. With a third of Earth's gravity on Mars, a planet more significant than the Moon, but much smaller than Earth, the typical jump would be about 1.18 meters. Same situation on Mercury, since it has a surface similar to Mars. Only 17% of Earth's gravity exists on the Moon's surface, the only place other than Earth where people have dared to leap. You can jump with the same force as on the Earth, ascend to a height of 2.72 meters, 10 feet, and hang there for around 4 seconds. An average man might jump for around 15.75 meters on Ceres, a dwarf planet in the asteroid belt between Mars and Jupiter's orbit. Enceladus, a moon of Saturn, spews geysers into space and conceals a vast ocean of liquid water beneath its icy surface. Although it's only 14% the size of Earth's moon, it may be capable of supporting life. Enceladus would be much fun to jump on. Before floating back down, you would ascend roughly 42.6 meters or 140 feet, landing with the same force as if you had jumped on Earth. The alternative to a 42.6 meter jump is a 57 meter, 187 foot one. You would need to leap onto Miranda, the moon of Uranus, to do that. A typical hop on Phobos, Mars's moon, might reach heights of up to 773 meters, 2,536 feet, which would keep you in the air for about 17 minutes. NASA's Philae lander had to lock harpoons into the surface of Comet 67P's weak gravity field to remain in place. Comet 67P is a member of the Jupiter family and was first discovered in the Kuiper Belt. You imagine what would occur if you leaped here? So, if you leaped upon Comet 67P, you would float away into space. Alternatively, to put it another way, your legs are strong enough to outrun the escape velocity of this space rock. You might have been tempted to leap into the sun after watching all these high jumps, but do not. The gravitational pull is just too great for you to jump onto the sun. In conclusion, scientists and space enthusiasts have long been intrigued by how high we can jump on other worlds in the solar system. We have learned a lot about the effects of gravity and atmospheres on human jump capabilities from early studies in the 20th century to current studies using cutting-edge equipment. We now know that leaping on planets like Mars and Venus would be challenging due to their weaker gravity and thicker atmospheres, whereas jumping on planets like Jupiter and Saturn would be simpler because of their stronger gravitational pull. Additionally, we know that atmosphere significantly impacts human jump height, with parameters like air pressure and composition having an impact. However, we still need to fully understand the heights to which humans can jump on other planets. As we explore the solar system and learn more about the planets and their surroundings, we may anticipate learning more about the heights to which humans can jump on other planets. We could feel the rush of weightless, limitless flight one day as we step foot on new planets and moons, and we might even be able to leap higher than we ever imagined. Today's video has come to an end. Remember to give this video a thumbs up and subscribe to the channel to view more content. Remember to click the bell symbol to receive notifications when new videos are posted. I will leave you with this and hope to see you in the next video.